went down the stack, up the stack, then used an application on top of the board. We will go down again to the boards with Kaspar. You heard a little bit about Ariel OS already, and he is coming with a proposal how to maybe join forces to have a better board abstraction.
Hi, everyone. Welcome to my talk, Beating Heterogeneity Towards Structured Board Descriptions. So yeah, as Martin said, so the context is how to get a RIOT running on a new board, right? This is what I'm talking about. And basically, I'm going to go through what I think is maybe an issue, and I will briefly talk about how other OS handle this, present an idea, present a proof of concept, and then go to insights and perspectives on that. Right, so adding boards. Well, it is necessary, right? I mean, RIOT runs already on a lot of boards. I counted 280s. Matthias had 241 on the introductory slide, so let's say hundreds, right? But they're mostly dev boards, and so a poor Go user with his own board has to do something to make a RIOT actually compilable, right? And or just takes a dev board and wants to attach a sensor, and that also already changes basically the wiring of the board, so that needs to be handled somehow too, right? We get some scoping. I'm talking about the board definitions, not about the microcontroller support. Let's assume that is already there for the board, right? And as said, like adding a sensor for me, that means there's basically a new board. All right, adding boards. Adding boards is actually very well documented in RIOT. Thumbs up for that. I looked at it as like flowcharts and pages of documentation examples. Is really actually a doable project, even for an outsider, right? But this it is tedious and pretty manual. For example, you need to touch a lot of files. Like each board needs at least 4 different make files and 2 header files, and you need to know what to put in there. I'll give you some examples for the NR52DK. It has a debug UART, and the debug UART is connected to the pins 6 and 8. That has all green LED on pin 13. That needs to be spread across these files, and that becomes. We need to know from all of this. Right? I will go into details for the UART configuration. Our fact that there's a UART on pin 86 here is actually mixed with the choice, right? The choice to use the UART E0 peripheral. It is an arbitrary choice. What is also in there is stuff that is required by the implementation. For example, that if you are using the UART E0, what IRQ number has that is like down here on this. Something that the implementation, the underlying, requires to put that in the configuration. Same with the ISR UART 0 down here. Like which is the function name of the ISR handle. And in order to write this, you need to understand the implementation, even though the implementation clearly expects exactly that to be written there. For the LED is a bit different. I mean, the fact that there's a green LED on pin 013 and it's active low, here we can't even talk about implementation details because that is the actual implementation of macros. What's hidden in there? Here we clear for the LED on macro, we clear the register bit that is active low. So that information is somehow encoded in that, right? And actually the LED needs a couple more entries for SAW. So the workflows, these facts, right? They need to be collected somehow from datasheets. Then you need to know how to express them in RIOT, how to put them in the headers. Then you need to add in the requirements by the implementation. And then the design choice of RIOT, they need to be known, right? And then that has all to be put into the RIOT files for a board. And by the way, of course, again, for the next board, right? And for the next board. So we have this right now, I think, run roughly 280 times. And it's the same kind of work every time because if it takes one work for one board, it takes n work for n boards almost. Because they do share some stuff, but I think that's actually not feasible for new projects. It's also a lot of work, especially when it comes to maintenance. If something needs to be changed, like the soil configuration when that is updated or improved or something, or when an MC wants to add DMA support, are we going to change all of these files? I think that becomes impractical. And a recent example is actually like the pulling out of the adding of the SPDX license headers that turned out to be, it was split over 4 pull requests, I think, because so many files had to be touched, right? So that is like, let's work, right? So takeaways. RIOT defines the boards in multiple header files and make files, and they encode facts and design and config choices and implementation requirements. And I say that causes both issues for adding a new board and also for maintaining them. Right, so how do other operating systems do that or handle that? I looked at Natex, Minute, TalkOS, Ariel OS. They're doing the same intermingled build system and code or headers, right? Then there is ESP Home and Tasmota. They start doing some generation from structured descriptions, but both seem to me rather limited in scope, like a very limited amount of actually base microcontrollers, and then basically more configuration that they are like doing in there. And yes, then there's Zephyr. Zephyr is basically the state of the art in this. They have like the most board support of them all. And they are using device tree source files and YAML files, kconfig, CMake files, but all the interesting stuff is in the DTS files, and they're generating board support for that, which is extremely interesting. And I think we should do something similar. Unfortunately, Zephyr in these device tree files, they're also mixing like facts and opinions and also what their implementation requires, right? So unless our implementation looks the same as the same requirements, we cannot just use all of that, but the facts we can use. So for the takeaways, we cannot just use Zephyr as device tree files, but we can and we should reuse the facts that are in there. We can pass them out. Okay, so now we come to my idea. Let's the plan. Step one, let's have a description of all the facts of the board. Like for example, the board has an NL5224T blah blah X microcontroller, or there's a green LED here, or an I2C with that sensor there, right? And the idea is really just reduce it to the facts. If another RTOS would, under reasonable definitions to be made, describe it differently, then the fact. Christian said it in those words. Thank you, Christian. Well, step two, write a generator. Like a tool that can read those facts, that knows RIOT's implementation requirements and choices, and then knows how to generate board support files. And then auto-generate the support for a board, right? And of course, have many facts files, fact files, reuse the same generator, and then generate all the board support, or a lot. And to be honest, my plan was, of course, to do this for Ariel OS, right? Auto-generate or Ariel board support from those fact files. But, well, of course, the facts are facts by definition. So the same fact files can be reused across like operating systems like in RIOT or in Ariel OS or wherever. So, and of course, I did a proof of concept for that. I started with just writing down facts in YAML because I think it's easy to write, easy to read. And sat down and started coding and wrote. And yes, at some point I could generate all the Ariel OS boards we have. It's only a small number, like 30 or something. I could generate all the board support. But I'm going to a RIOT conference, so I had to see what RIOT to, and it was actually interesting if it works out, and it did. It was a bit more difficult because of these of some design choices and opinions that in Ariel is a bit more limited, so they didn't manifest there. RIOT has them already, right? For example, that there should always be one UART configured. And also generating RIOT board support requires the generator to know these requirements by the implementation that I talked about before. The generator needs to know them too, because someone they need to get into the board support. So I need to find a way to feed this kind of metadata into the generator. But yeah, with that in place, I could actually generate a board from the YAML description and boot it, and it worked. Yeah. So what works? It does parse a microcontroller, debugger UART, LEDs, and buttons, and this metadata per RTOS. And a lot is missing, everything else basically. But I think it's already very promising. That brings us to my insights and perspectives. So what I learned is that the difference between like facts and opinion and design choice and configuration, that becomes very, very blurry quickly, right? Like this just becomes blurry because configuration opinion is it's very close. But the generator definitely needs more than the board facts to work for both Ariel and also RIOT. basically for RIOT, there's some work for each microcontroller family that needs to be supported, but it's not much. Yeah, and for the perspective, actually, I'd be happy if we could start gathering these facts files together, and then both RIOT and Ariel and others could use them. And I believe with the infrastructure like that, with some investment, boards basically port themselves at some point and can be fully automated ported. Thank you.
Didn't need to rush you, but okay. Any questions? Okay, yeah, fine.
Yeah, thanks. Aren't there any predefined MCU description formats, or do we have to make our own? Because I feel like if we're going to make, I feel like there's a chance we make a really huge mistake designing these description files, and then like 2 years down the road, we discover, oh well, we should have considered ABC when writing these files, and we've got a bunch of these files, and we'll see the changes them all over again. So is it kind of predefined format we could use?
Well, I have. Yeah, but I know what the DDS source files, divide source files, but honestly, I don't think it really matters much, right? Because if it's structured enough, it's easy to convert from one format to another. And I already converted it a couple of times already in the generator, what feeds best is what I needed. And the actual format is not so important. I think it's an implementation detail. But having it structured is important. And I tried, for example, of course, I tried to read out the device tree source files and learned the hard way that the Rust support, like the Rust device tree source parsers, are not where they should be, right? So that is not a universal format for me. That's why I started with YAML in the first place. But I don't think the format matters much.
But still, is there a predefined format?
I don't know. I'm not aware.
Question was a sense of format, just so that the audience can make it.
What do you mean for if I have one, if I have device one, if I found one, if there is does something like this?
Like specification for such.
So I'm not aware of any, no.
Did you look for it?
Briefly, yes. But,
are there more questions? Oh, I think that was actually a microsecond burst.
That's a patient perception of reality. Where would the opinion part of the board configuration go? So basically, we are stating text. For example, there's a development board from some manufacturer, and it has like 3 or the board in my bag has 3 ports that are for general development. Each of them carries UART, SPI, and some GPIOs. And where would you state that these pins shall do this function?
Well, some of it is maybe pre-wired. It's about the wiring, right? So
the wiring is only to the pins, to the thing where I can plug a wire in. But
yeah, now you see what I mean with the difference between facts and opinion and configuration becomes very blurry quickly, right? So my idea was actually that, I mean, it's the same as we have right now in RIOT, that there's like the dev boards, and if you want to attach an I2C sensor, usually the way to do that is to, in your application, then use the pins as I2C or edit it to the perifconf, right?
Yeah.
And the same thing can be done, you know, as soon as you have the structured board definitions that are built from facts, you can also add configuration to that on top of that, easy, right? Just
is this already in this?
No, in my concept, I don't do it. It's just like it can play it with more information and more code generators.
So it's just about, in this case, it would be this pin of this MCU goes into this pin where I can plug in my one connector and put it onto the sensor. And
it's more complex than that, actually, right? Because it depends on the microcontroller, but any pin can be used for everything, right? And that can be encoded in some description form, right? I do that, right? So then there's like, for example, we have a shield. And for the MCU meter or in the board metadata, we have the Arduino pin map, right? So then there's an easy way to say I want to map that shield to that pin, to that SBC map.
Yeah. Right now, we have this shield concept for Arduino.
Yeah.
And I don't know of any board that has more than one shield connector. But for many development boards, it's quite the opposite, that there are multiple boards of the same kind.
Yeah.
Like Marian mentioned to me, there is an Olimex pin map definition, and I know there is some definition by Adafruit that has a specific mapping where you can plug in, for example, the display to one board and temperature sensor to the other board, but you can also swap them around, and this is an application configuration. But I think it would be kind of the board configuration thing. Is this? It's not part of the concept, as I think.
The point is that at some point it doesn't matter anymore, right? Whether something is hardwired or whether you want it to be wired that way is just a matter of different description of it, right? There's no difference anymore. I think it makes more sense to only collect the facts as they are facts, right? Yeah. As one part of the input. But if I want to have the LED on at boot time or off, right? And if I make that a flag in the description format, it's the same as in description. It's the same as if I say the LED is hardwired to be active low.
And I'm sorry for extending my question. There are boards that are not microcontroller boards. You can extend them and you can connect them. And these connection points might be mix up might be a board description that is kind of drawn into the other board. So there's a connection point. And it would be nice to model this somehow.
Yeah,
right
definitely.
now, it's not there. Is there somehow a way to model it?
Definitely, it's not there. That is on the to-do list, like how to handle shields. But yeah, I think I will do it like something. We could do it like it is open, of course, but it's not hard to do at all.
That's good. Yeah, there was a quick here. Yes, sorry.
Well, thank you for the presentation. I have two short questions first. No, wait. First question: how easy would it be to extract the facts from existing DTS or whatever files are there, for example, from Fire or Linux? Is it something that you can just like programmatically do and say, okay, these are facts, and basically you're trying to transfer to the system, or is something that is?
Yes, absolutely.
Okay, so that's a second question. Have you thought of inheritance between files? For instance, what happens if you have an MCU family that have very similar configurations, and then you have some family that's slightly different from this thing? Can you also inherit the?
Yes, right now I'm just merging the YAML tree struct, right? I'm just running that, but there has to be more sophisticated things for this. But
okay.
Yeah, maybe even device-free source files, for example, because they already have that solved. If not used in the ZAP file way, but in a more generic stuff, can actually do this, right? That could be, but there was no good Rust crate for that, so I didn't use it.
I guess. That was very quick. Just because a detail on the RIOT specific context. How do you handle the fact that certain boards are kind of abstracted in 2 or sometimes 3 levels, like for instance the nuclear boards, that all of them share more or less the same structure, but then you kind of inherit what more or less as I was saying. Are you taking this into account, or all the generation happens like raw? Like you generate all the files for all the boards. You don't care if 20 boards have shared half of the code.
So for the output, I just right now I just dump it there, right? For all of them, which is duplicated, because I think that is not the source of truth, and I don't care if generated code is duplicated so much, right? And in the source files, as said, right now I can merge stuff. I realized that even the nucleos, they have slight differences, right? And as soon as the description files have all the ifs for all the hundreds of nucleos, they're not so nice anymore. I don't know, experience. We need experience for that.
Are you using the Cortex M SVD file system in your description files?
Good question. That is, I think, way lower, right? Because I said we look at the microcontroller the microcontroller support. The SVD files, they would contain information like the alternate functions, I think, right? That is in there. Not the Cortex M ones, but the ones that are specific for the board, for the MCUs.
Tell you something about the memory layout and so on, which is information you may not.
Yeah, but that information is already on an MCU level. There are not so many MCUs. We have that. We could. The SVD files are buggy. I mean, in Ariel OS, we have like a whole stack for different stuff, right? And for example, for the STMs, we don't use the SVD files anymore because there's like one for each of the STM32 families, for example, and they are all slightly different and buggy, and they're not really maintained, right? So there's other source information which have even more for that, like the STM32 cube library, but that's a different story. We are in a higher level, way higher level.
That's what I want to get next, because you looked at many different tools. The CubeMX, for example, obviously does something graphically and does even consistency checks and so on. Are you able to produce we use something from the vendors, because each vendor provides its own set of interesting tools. They must have that information.
Yes, but they are kind of hiding it, right? Like, for example, the cube stuff. It has all the Nucleo information, but even the license on that information is not clear. It has a custom license, right? So even using that is not so difficult. But we use that in Ariel OS or some of the dependencies on a way lower level. But for this wiring on the high level, which pin goes where's the LED? They actually bought if there's like a oscillator on there or something. That is not really accessible. There's no format for that, right? But there are the Zephyr device tree files. They have all that info. Then there's other stuff now with LLMs. Actually, there's other ways to get to a simple YAML description, right? So getting that information is actually not that hard. The juice is in the generator. And that is also not super hard to do, but you need MCU stuff, right?
When I was listening to the presentation, there's now the market descriptions came. I know it's not the same thing. This actually is just the description. This is very good for sort of common format across vendors.
I don't think it matters much. See, like I have like a backup slide somewhere. I just asked Google Gemini to look at one of the descriptions and get me the description written in that format that just matches the YAML I just had, right? So the only thing that needs to match is the generator needs to be able to read that. If there's a format, nowadays we can just convert like 2 pages of YAML into another. It just doesn't matter.
Yeah, I agree. Certainly facilitate the whole data model.
Yeah, exactly.
Thanks.
I think for one last question, you still have Dennis.
Three questions. First question would you consider hardware constraints also as for example, the multiplexer of the NRF is fully matched and you can move anything there out to any level and grow. But a lot of the other vendors have constraints, so we can only use certain set of things in certain roles. And we have to allocate carefully, for example, if you use in the AID, the ZACOM run, you cannot use the ZACOM run for another job. Those constraints.
Yes, I would put them in there because if the generator knows about them, and we can get them from the SVD files, by the way, if the generator knows about them, it can do much more automatically, right? Because the fact is that some debug UART is on some pins, but if those pins can only be used with ZACOM 1, right? That is like something that can be automated. And yes, I will do that, of course.
Does actually go in the same direction board constraints? For example, it could be if sensors report, it could be that they can be powered on or powered off with the GPIO files.
Mm-hmm.
It could be that multiple sensors share the same power and able to would that also be something that would be important there?
Sure. As said, the juice is in the generator, right? And not everything needs to do everything. If yeah.
And the third question would be, do you intend to also add a validator? For example, for STM, the Cube IDE has a validator, so that hardware designers actually can see if what they model or what they design can actually be implemented. But microchip, for example, doesn't have that. Could end up with a PCB design that can never be used. Obviously, a stupid error, but the human will have to carefully check with every reference can use select communication.
Good question. I didn't think, I thought more about validating that the description itself makes sense. Like, for example, if a pin gets used multiple times, the generator needs to warn about this or just not work, right? But I was assuming that the facts file is correct. That was my intention there. Of course, it probably won't be while writing it. Maybe it makes sense to have
to the natural some validation with the facts file in the inconsistent not fulfilling.
Yeah, agreed.
Direct answer? Direct answer. Plenty of otherwise, otherwise Tom doesn't have enough time for this.
Very brief answer. I'm probably not for RIOT, but with the constraints that are on type system constructors in Rust, if an application builds on Ariel OS with the board as you described, that should be a validation provided that the HAL is correct.
Yeah. By the way, we have a breakout session, I think.
Yeah, I guess that is a nice topic that can be discussed during the social. So also for maybe the breakout session. That's interesting. So nice. Thank you, Kaspar.
Yeah.